Alright guys, this will be the last tutorial for Form 4 Chapter 3. So in this tutorial, we will discuss on some past year question as well. Okay, so this tutorial we will focus on how to do calculation by using chemical equation. Okay, how are we going to do a calculation by using a chemical equations? Okay, alright. So okay, let's start with the first question. This is a past year question from SPM 2007. Alright. So in this question, they give us a chemical equation and they ask us the mass of lead nitrate needed to produce 3.6 decimeter cube of oxygen. Okay. So when we want to do calculation involve chemical equation, so first of all, we need to have a balanced chemical equation. We must have a balanced chemical equation. So for this question, the balanced chemical equation is provided. So they already give us the chemical equation. So we can just copy it. So 2PbO. Okay, so I just write it here. Okay, 2PbO. Sorry, PbNO3. Okay, 2PbNO3 to become 2PbO. So then you have 4NO2 and also O2. Okay, so this question they already provide us the balanced chemical equation. So after we have balanced chemical equation, the next thing we must ask ourselves what we have and what we want. Always ask ourselves what we have and what we want. Okay, so we are looking for the mass of lead 2 nitrate. So we want to find the mass of lead 2 nitrate. So lead 2 nitrate is this. Okay, underline the lead 2 nitrate. And we are looking for mass. So you write mass and you put question mark. Okay, so what else we know? So the question tells us we have 3.6 decimeter cube of oxygen gas. So here this is the arrow. It's a typo arrow. It should be dm cube, not dm minus 3. So they shouldn't put a minus here. Okay, so they make a mistake here. Should be dm cube. Okay, so we have 3.6 dm cube of oxygen gas. So let's find our oxygen gas. So this is oxygen gas. It's 3.6 dm cube. Okay, so now we know what we have and what we want already. Okay, so after that, when you come to chemistry calculation, always start with mole. Okay, always start your chemistry calculation with mole. So we can find the mole for this one first, the oxygen here. Okay, so 3.6 dm cube. So dm cube is volume. Okay, so we have volume. So we can convert the volume to mole first. Okay, we have to convert the volume to mole first. So we learned in lesson number 2, volume and mole can be converted using molar volume. Okay, to convert volume to mole, we use molar volume. Okay, so the operation, since we want to find mole, anything convert to mole, divide. Okay, anything convert to mole, use divide lah. Okay, so then okay, we put in the value. What is the volume we have? Our volume is 3.6. Divide, what is the molar volume here? So let's check the molar volume. So the question tells us that the molar volume is 24. Yeah, the molar volume is 24. Okay, so we will use the 24 lah. Okay, so we just use the 24 here. Okay, so 3.6 divided by 24. Okay, so we key into calculator 3.6 divided by 24. So we will get 0.15. Okay, mole. Because we are looking for mole. So you need MOL, mole. So now we get the mole already. So this mole that we have is for who? This mole that we have is referred to oxygen. So now we have the mole of oxygen. Okay, so if you want, you can write like this. Okay, so probably you can write this is the mole of oxygen, O2. Okay, so now we know the mole of oxygen already. But are we looking for oxygen here? No, we are not looking for oxygen. We are looking for lead nitrate, right? True or not? Our main concern is to find the mass for the lead nitrate. Okay, so now since we know the mole of this, so we know the mole of oxygen, which is 0.15. So now we need to find the mole for lead nitrate first. Okay, so when we know the mole of one substance, we can find the mole of another substance by using ratio. So you can write down like this. So you can write refer to the ratio. Okay, you refer to the ratio. So the ratio we refer to lead nitrate and also the oxygen. Okay, we refer to the lead nitrate PbNO32 and also the oxygen. Okay, so the ratio, we look at the number at the front of the equation. So lead nitrate, the number in front is 2. Oxygen in front, no number, that is 1. So 2 to 1. So the ratio is 2 and 1. Okay, so now when we know the ratio, how to find the mole? Okay, so as you can see, the ratio for oxygen is 1 and the lead nitrate is 2. So 1 become 2. Okay, so when we have 1 oxygen, we have 2 lead nitrate. Okay, when we have 1 oxygen, we have 2 lead nitrate. So 1 to 2 means double. So the mole of lead nitrate should be double of oxygen. Okay, see, you look at it again. So as you can see, oxygen here, the ratio is 1. The lead nitrate here, ratio is 2. So lead nitrate always double of oxygen. So now we know the mole of oxygen is 0.15. So lead nitrate, the mole will be double, okay, of oxygen. So the mole of the lead nitrate, okay, the mole of the lead nitrate will be double of the oxygen. So 0.15 double, so become 0.3 mole. Okay, so just a simple ratio calculation. Okay, just a ratio. So now we know the mole already. So now we know the mole of the lead nitrate. So what we want in the end? So in the end, we are looking for the mass. So in the end, we are looking for mass. Okay, so how to get the mass? Okay, so now we can change the mole to the mass. Okay, so when we have mole already, we can convert the mole to the mass. Mole can convert to mass using RAM. So you can convert mole to mass using RAM. And the operation, mole change to something else, we use multiplication. Mole change to something else, we use multiplication. So the mole is 0.3. So we need to get the RAM first. Okay, we need to get the RAM for our lead nitrate. Okay, so now to find the RAM for lead nitrate, so we don't need to bother the number 2. The number 2 in front only for balancing. Okay, number 2 in front only for balancing. You don't include in RAM calculation. Don't include in RAM calculation. So we need to find the RAM of your lead nitrate. Okay, so lead nitrate, what is the RAM? Okay, let's check. Okay, so they give us the RAM for lead, nitrogen, and oxygen. So we just add in. Okay, so for lead, we have 207. Nitrogen is 14. We have 2 nitrogen times 2. Okay, then we have oxygen. Oxygen, the RAM is 16. So we have total 6 oxygen here, okay, in the lead nitrate. So then we key in the whole thing here to your calculator. Okay, so we have 207, and then we add on with the 14 times 2. Then we have a 16 times 6. So you get 331. So that is the RAM. Okay, so now we have the RAM already. Just key in the RAM. So 0.3 times RAM, 331. Okay, so we put this in the calculator, 331 and also 0.3. Okay, so when you key into calculator, the final answer you will get is 99.3. Okay, and what is the final unit? Since we are looking for mass, the final unit is gram. So 99.3 gram. Okay, 99.3 gram. So the final answer is B. Okay, 99.3 gram. Okay, so this is how you do step by step. Okay, alright, this is a real SPM past year question. Okay, next one. So the next question, this is also a past year question. So this is also a past year question. Okay, so the following chemical equation represent photosynthesis process. So we have photosynthesis process. So the question asks, what is the mass of glucose that is produced if 1.2 dm³ of carbon dioxide is used? Okay, same thing. So when we want to do calculation involve chemical equation, so first of all we must have a balanced chemical equation. So in this case, the balanced chemical equation is provided. Okay, so they provide us the balanced chemical equation already. Yeah. So now I just copy the whole equation. Okay, again, I just copy the whole equation again. Okay, now, next thing, we must ask ourselves what we have and what we want. Okay, we need to ask ourselves, okay, what informations that we have and what informations that we want. Okay, what we have and what we want. Okay, so if you look at the question, okay, what we have and what we want. We are given 1.2 dm³ of carbon dioxide gas. So we are given carbon dioxide gas. So underline the carbon dioxide and you put the information here. You are given 1.2 dm³. So this is the information you have. Okay. So now what we want, we are looking for the mass of the glucose. Okay. So mass of glucose. So from the equation, who is the glucose here from the equation? This one, C6H12O6 is the glucose here. C6H12O6, this is your glucose. So, okay, all right. So in this case, okay, so in this case, we are looking for the glucose. Glucose is C6H12O6. This is your glucose. So the glucose, we are looking for the mass. Okay, so we can write mass equal to question mark. That is what we want. Okay, so now we know what we have and what we want already. Okay, next one. Always start your chemistry calculations with mole. Okay, convert whatever thing you have into mole first. So we have 1.2 dm³. dm³ is volume, so we can convert volume to mole first. To convert volume to mole, we use molar volume. We learned this in your lesson number 2. Okay, so when we want to change anything to mole, we use divide as the operation. So let's do it. So 1.2 divide, okay, when 1.2 divided by the molar volume. So what is the molar volume here? The molar volume is 24. Okay, so 24. Okay, so we take 1.2 divided by 24. Okay, so you will get 0.05 mole. So this mole is referred to who? This mole is referred to carbon dioxide, yeah, because we have the volume for carbon dioxide. Okay, when we given volume for carbon dioxide, when we find the mole is referred to carbon dioxide as well. So now we know the mole of carbon dioxide. Okay, so now we know the mole for CO2 already. So we need to find the glucose. So we need to find the mole of glucose. When we know the mole of one substance, we need to find the mole of another substance, because now we know the CO2 is 0.05 mole. Okay, but in this question, we are not looking for CO2. In this question, our main purpose is to find the glucose. So the glucose, how many mole? So we need to do ratio. Okay, remember, when we know the mole of one substance in the equation, we can find the mole of another substance in the equation by using ratio. Okay, so you can write down like this. Okay, so you can refer the ratio. So the ratio we refer between what? The ratio is we refer to carbon dioxide, which is what we have, and glucose, C6H12O6, which is what we want. Okay, so if you refer to the ratio, okay, so the ratio is actually the number at the front part of the equation, the number in front of the equation. So carbon dioxide is 6, glucose in front no number, that is 1. Okay, so we have 6 and 1. Okay, 6 and 1. So refer to the ratio. Okay, I write like this. CO2 ratio to C6H12O6. The ratio is 6 and 1. Okay, so this is the ratio. Okay, so from the ratio, what we know? Okay, so when CO2 got 6, glucose only got 1. Okay, so the glucose is always 1/6 of the CO2. Okay, and when we have 6 CO2, we only have 1 glucose, okay, 1C6H12O6. So you can find it like this, okay. So you can do mathematics, or if you are weak in mathematics, you can change to fraction, no problem, okay. So here you can use your own method to do the ratio calculation, okay. You can use your own method here, okay. So let's say we can convert this, okay. So we can find the mole of your glucose, C6H12O6. You just need to take the 0.05 divided by 6, okay. You divide by 6 will do, okay, because the ratio is 6 to 1, okay. When you have 6 CO2, you have 1 glucose. So the glucose is always 1 over 6 of the CO2 only, yeah. So you can convert to, you can key into calculator 0.05 divided by 6. So you're gonna get 0.0083 mole. So this is the mole you have, okay. So if you don't want to do in this way, also can. If you don't want to do in this way, you also can use other mathematic method like this. You can change this ratio to become fraction. CO2 ratio you can change to over, C6H12O6 become 6 over 1, no problem, yeah. So then we know the mole of CO2. CO2, the mole is 0.05. So you change to 0.05. So then you do your cross multiplication, blah, blah, blah. In the end, you will still get 0.0083 mole. No problem, yeah. You use your own method to do the fraction, okay. So to do the ratio, okay, to do the ratio. So now we found the mole for the glucose already. So we have mole already. So in the end, we need to change the mole to the quantity that we want. So now you already have mole. Now we want to change the mole to the final quantity we want. So what we actually want, we are looking for mass. We are looking for mass. So now let's do the final step. Mole can be converted to mass. So mole and mass can be converted using RAM. To change the mole to mass, we use RAM. Okay, so mole change to something else, we use multiplication times. So what is the mole? 0.0083. So multiply, we need to get the RAM first, okay. So what is the RAM of the glucose? So we need to find the RAM for your glucose. Glucose is C6H12O6. So how to find it? Carbon, the RAM is 12, you multiply by 6. Hydrogen RAM is 1, you multiply by 12. Oxygen RAM is 16, you multiply by 6. Okay, so you just add everything together here. Okay, so you just add everything together. So here, when we add everything together, you will get 180. Yeah, so this is 180. So I should put a space here, sorry. Okay, I move here. 6 times 12, 12 times 1, 6 times 16, so I'll get 180. So 180 is the RAM for the glucose. So 180 put here, okay. So then you multiply with the answer 0.0083. Okay, you multiply by 0.0083, which is the mole that we have. Okay, which is the mole that we have. Okay, so if you do it, you will get the final answer. It's about 1.49 gram. Okay, 1.49 gram. So if you look at the answer, which answer is 1.49? There's no 1.49 here. The nearest answer is 1.50. Okay, the nearest answer here is 1.50, which is B. Okay, so this is the real SPM past year question in year 2017. Okay. Okay, so let's move on to another one. So the next question, this is SPM 2018. This is SPM 2018. All right. So they gave us a chemical equation, and then they asked us which of the following statement is correct. Which statement is actually correct? Okay. So the first one. So the answer A say that 2 nitrogen molecule react with 6 hydrogen molecule to produce the 6 ammonia molecule. Okay, so this is wrong, because if you look at the nitrogen here only got 1, it's not 2. Okay, and even if they want to put the 2, they should mention it as what? They should mention 2 mole. They should use mole. Okay, the number in front here, the number in front your equation, okay, represent the mole ratio. Okay, the number at the front represent mole ratio. Like for example, the 1 here is 1 mole, the 3 here is 3 mole, the 2 here is 2 moles. So you don't see they use any words mole here, so it's wrong. So answer A is wrong. Okay, so answer B say that 1 gram of nitrogen react with 3 grams of hydrogen to produce 2 grams of ammonia. So nitrogen, the number is 1, sounds good. Hydrogen, the number is 3, is good. Ammonia, the number is 2, is good. But this answer is wrong. Why? The number in front, the substance, okay, the number in front the substance is mole ratio. So it is something about the mole. It is not about the gram. It's not the mass. Okay, so the number in front here is the ratio for the mole, not the ratio for the mass. Okay, like for example, let's say we have something like this. Okay, we have 2A, 2B plus C. The 2 here is not 2 gram, you know. The 2 here is 2 mole of B. Okay, so the C here, the number 1 in front here is not represent 1 gram. It's actually 1 mole. Or the number in front, the chemical equation representing the mole ratio. It is mole, it's not gram. So answer B is wrong as well. Answer C, okay, so for answer C, they mention 1 mole of the ammonia gas is produced when 0.5 mole of nitrogen gas react with 1.5 mole of hydrogen gas. Okay, this one looks confusing. Okay, is it true? Okay, let me show you how to do this. Okay, 1 mole of ammonia is produced when 0.5 mole of nitrogen gas react with 1.5 mole of hydrogen gas. Okay, so how to do this? Okay, we copy the equation first. N2 plus 3H2 become 2NH3. So this is the chemical equation given here. Okay, so they told us the ammonia is 1 mole. Okay, so we write here ammonia, here is 1 mole. Okay, then after that we have 0.5 mole nitrogen gas. So nitrogen gas here is 0.5 mole. Okay, then the hydrogen gas is 1.5 mole. So it's 1.5 mole. Okay, so how to know whether all the mole value here is correct or not? Okay, how to know whether the mole value here is correct or not? So we can try to simplify it. Okay, we try to simplify. Okay, so if we simplify it, okay, if let's say we simplify, we can divide all the mole here with the smaller mole value. Okay, we can simplify by dividing all the mole with the smallest value. So if you look at these 3 mole here, the smallest value is 0.5 mole. So you divide all of them with 0.5. Okay, you divide all of them with 0.5 mole. Okay, so if you do this, okay, you can simplify. Okay, so the first one 0.5, 0.5 simplify, you get 1. So 1.5 divide 0.5, you get 3. 1 divided by 0.5, you get 2. So now you can see after simplify, this number is exactly same as the number at the front, 1, 3, and 2. So yes, it is correct. Okay, so it's correct here. Okay, so this is how we do it, which is just a simple comparison. So the answer C is correct. Okay, the answer C is correct. Okay, if you don't want to do this, you can also double check. For example, they say you have 0.5 mole of nitrogen. Will you get 1 mole of ammonia? Let's try. So if let's say our nitrogen is 0.5, so we do ratio 1 to 2. So 1 to 2 means double. Okay, 1 to 2 is double. So the ammonia should be double of 0.5, which is 1 mole. So ammonia is 1 mole. Yes, the ammonia we get 1 mole, no problem. Yeah. You also can double check like this. Okay, let's say we have 0.5 mole of nitrogen. Can we double check? Is the hydrogen 1.5? Can we double check? Okay, so let's say we have 0.5 mole of nitrogen. Let's check the hydrogen. So let's check. Okay, so now if the nitrogen here is 0.5, how much hydrogen we have? According to ratio, nitrogen is 1, hydrogen is 3, 1 and 3. So 1 and 3 is triple. So when 0.5 triple, you get 1.5. So the hydrogen is 1.5, which is same as the answer here, hydrogen 1.5. Okay, so you can use the answer to check, no problem. Yeah, it's not a very hard calculation. Yeah, you can use the answer to check back, no problem on this. Okay, all right. So now we can try to do another one. This is another SPM past year question. Okay, this is SPM 2018. This is 2018. Okay, so same thing. You are given a chemical equation. So we copy the chemical equation first. Okay, let's copy the chemical equation. Okay, so I'll copy the chemical equation. Zinc plus 2 HCl to become ZnCl2 and H2. Okay, just copy it first. Now I need to ask myself what I have and what I want. Okay, so I need to identify what we have and what we want. So I have 6.5 gram of zinc. So I underline the zinc and I write 6.5 gram. This is what I have. So what I want. So I am looking for the volume for hydrogen gas. So I want volume of hydrogen gas. So from the equation, this is my hydrogen gas. I underline and I am looking for volume. Okay. So by doing this, I already know what I have and what I want. Okay. Always identify what you have and what you want. Okay. Then you can convert anything you have into mole first. Okay. You can convert anything you have into mole. So we have 6.5 gram, which is the mass. So we can change the mass to the mole first. Okay, we can convert the mass to the mole first. Mass and mole related by RAM. So anything changed to mole, use divide. Okay, so now from here we can find the mole of your zinc. Okay, from this calculation you can find the mole of zinc. Okay, so we take the mass 6.5 divide by the RAM. RAM for zinc is given here 65. So 6.5 divided by 65, we will get 0.1 mole. Okay, so now we found the mole for zinc already. So now we need to get the mole of another substance. Okay, so after we found the mole of zinc, we need to find the mole of another substance, which is hydrogen. Okay, because remember, our main objective is to find hydrogen. So when we know the mole of zinc is 0.1 mole, we need to find the mole for the hydrogen first. So in chemistry, when we know the mole of one substance, we can find the mole of another substance by using ratio. You can use ratio to find the mole of another substance. So you refer to the ratio between zinc and also the hydrogen. Okay, look at the ratio. Ratio, you look at the number at the front. So the number in front of zinc is 1. The number in front of hydrogen is 1. So the ratio is 1 to 1. Okay. So when we get the ratio 1 to 1, 1 to 1 means the mole is the same. When they have same ratio, the mole will be the same. So from here we can find the mole of the hydrogen. Okay. So the mole of hydrogen should be exactly same as the zinc, which is 0.1 mole. Okay. Alright. So hope everyone know how to do the ratio here. Okay. So use the number in front, the formula, to do ratio. Okay. So now we know the mole for hydrogen already. So in the end, what we want, we are looking for volume. So how to get volume? So we already have mole. Now we can change the mole to volume. So to change mole to volume, we use molar volume. When we want to change the mole to volume, we use molar volume. Okay, so the operation is multiply, because mole change to something else always use multiply. Okay, when we have mole, we want to change to something else, we always use multiply. So what is the mole here? 0.1 multiply. What is the molar volume? So look at the question here. So the question here, they told us that the molar volume, the question saying molar volume is 22.4. So the molar volume is 22.4. Okay, so we go down here, we just put in 22.4. Okay, so when 0.1 times 22.4, we get 2.24. Okay, don't forget to put in the proper unit. Since we are looking for volume, the final unit for volume is dm cube. Okay, the final unit for volume is dm cube. So 2.24 dm cube. So you can double check your answer. Okay, so the final answer here, 2.24 dm cube, answer is C. Okay, all right, so C. Okay, so let's move on to the next one. Okay, so now we have another one more question here. Okay, so for this question, same thing, we have the chemical equation. Okay, we have the chemical equation already. So they ask us what is the mass of copper nitrate needed to produce 2.4 dm cube of oxygen gas. Okay, so as usual, first of all, always have a chemical equation first. Okay, so we have chemical equation here. So this is 2CuNO3 2. So they get 2CuO, 4NO2, and O2. Okay, so this is the chemical equation. Okay, so now after you have the chemical equation, the step number 2 is you have to identify. You must identify, you must ask yourself what you have and what you want. What you have and what you want. So we want to find the mass of copper nitrate. So underline the copper nitrate here, and we are looking for mass. So I write mass and question mark. So this is what I want. So what information is provided? What information is provided? 2.4 dm cube of oxygen gas. So we know oxygen gas is 2.4 dm cube. So in the equation, go to find the oxygen, which is O2, or underline the O2, and then you put 2.4 dm cube. Okay, so now we already know what we have and what we want. Okay, after that, always remember, chemistry calculation will start with mole. Chemistry calculation will start with mole. So we need to find the mole of your oxygen first. Okay? We need to find the mole for your oxygen. So oxygen, what information is provided? They give us 2.4 dm cube. So 2.4 dm cube is volume. So we are given volume, and we can convert volume to mole. So to convert volume to mole, we use molar volume. Yeah, and the operation is divide. Yeah, we learned this in your chapter of lesson 2. Okay, so what is the volume here? 2.4 divide. What is the molar volume? So the molar volume is given 24. So the molar volume is 24. So 2.4 divide 24, you get 0.1. Okay, don't forget to put in the unit. Don't forget to put in the unit. So since we are looking for mole, so the unit is MOL. Okay, MOL. Okay, so now we got the mole already. Okay, so after we got the mole, so the next thing now is what? The mole we found is belongs to, this mole that we have is belongs to what? Oxygen, right? Okay, because we get the 0.1 mole, and this mole is oxygen, O2. Okay, so but we are not interested with oxygen, right? For this question, our main concern is to find copper nitrate. We want to find copper nitrate, not oxygen. So when we know the mole of oxygen, how to find the mole of another substance, the copper nitrate? So same thing in chemistry, when we know the mole of one substance, to find the mole of another substance, we can refer to ratio. Okay, we can refer to ratio. Okay, So we will refer to ratio. So let me write it down. Okay. Refer to ratio. So the ratio we refer to the copper nitrate that we want and the oxygen that we have. So that's why I asked you to underline. So when you underline, so you know exactly which one you should focus. So the ratio, copy the number at the front, 2 and 1. Okay, 2 and 1. So now how you find the mole here? So using simple mathematics. So the oxygen, now you know the mole already, which is 0.1 mole. So how to find the mole of copper nitrate? So the ratio here, this is 1 and this is 2. So 1 and 2. So when we have 1 oxygen, we have 2 copper nitrate. So copper nitrate always double of oxygen. You can see when we have 1 oxygen, the copper nitrate got 2. So copper nitrate is double of oxygen. So from here, we can find the mole of copper nitrate already. So you can write mole of copper nitrate. So the mole of copper nitrate is double of the oxygen. Oxygen is 0.1. So from here, we will get the mole for the copper nitrate is 0.2. Okay, 0.2. Okay, so once we have the mole for the copper nitrate, so what is the last thing? What is the last step that we can do? So last thing, so we already have the mole, but what the question asks for? What the question want? So the question is actually asking for mass. So when we have mole, can we change the mole to the mass? So we already have the mole with us. So can we change the mole to mass? Yes. Okay. We learned that mole change to mass use RAM. We know mole and mass is related by RAM. And the operation, mole change to something else is times, multiplication. Okay. So let's do this. So our mole is 0.2. Okay. The mole for the copper nitrate is 0.2. So we need to multiply with the RAM. So we need to find the RAM for the copper nitrate. So in this question, the copper nitrate, the RAM, they give us already. You can see. So the copper nitrate, they give you molar mass. Okay, for some students, they don't know. Molar mass is exactly same as RAM. Okay. In chemistry, molar mass same as RAM. Okay. So here, must write a very important thing here. Okay, I write the tips. Okay, so in chemistry, you need to understand that molar mass is exactly same meaning as RAM. Okay, so sometimes they don't give you the RAM. They purposely don't give you RAM. So they give you molar mass to confuse you. So RAM same as molar mass. Okay, so now we are given the molar mass for copper nitrate. So they already give us the RAM for the whole copper nitrate. So we don't need to add ourselves like the last few questions. We don't need. So they tell us that for the copper nitrate, the RAM for the whole thing is 188. So we just put the 188 here. Okay, 188 is the molar mass for the copper nitrate. So molar mass same as RAM. So key into your calculator. 0.2 times 188, we will get 37.6. Okay. And not to forget about the unit. Since we are looking for mass, the final unit must be gram. So 37.6 gram. So let's find this. Let's check the answer. Do we have 37.6 gram? So the final answer, 37.6 gram. Yes, the answer is C. So we have it already. So this is how we do. We do it slowly and step by step. Okay, you do it slowly and step by step. Okay. So now let's move on to the next one. So here we have another one more question. Okay. So same thing for this question. We have the chemical equation. So I'll copy the chemical equation here. I'll copy the chemical equation again. Fe2O3. Okay, I just copy the equation first. Fe2O3 add with 3 carbon will become 2 iron, and then I will get 3 CO. Okay, so this is the equation. So when we have chemical equation, alright, and we want to do calculation, so you ask yourself what you have and what you want. Okay, you ask yourself what you have and what you want. So we have 128 gram of iron 3 oxide. Okay, so this is iron 3 oxide and it is 128 gram. Okay, so this is what we have. So what is the information that we want? So what we want? Maximum mass of iron. Okay, so we want to find the mass of iron. So here they put maximum, minimum, not important, not really important. So we are looking for the mass of iron. So from the equation, we underline the iron and we write down what we want, mass. Okay, alright, so by doing this, we already identified what we have and what we want. So this is what we have and this is what we want. Okay, next one, always start with mole. Okay, always start with convert what we have into mole. Okay, convert any information that we have into mole first. So we have 128 gram, so gram is mass. So we have mass, we can change the mass to mole first. Okay, we can change the mass to mole. Okay, so mass and mole is related by RAM. Okay, so when we want to change mass to mole, we use divide. Yeah, so the mass is 128, so we need to divide by the RAM. So this RAM is referred to the RAM of iron 3 oxide. Okay, iron 3 oxide. So let's find the RAM. So RAM for, okay, let's find the RAM for your Fe2O3. So let's find the RAM. So the RAM, so of iron is 56, oxygen is 16. So let's do it. So iron is 56 and we have 2 iron times 2. Oxygen is 16 and we have 3 oxygen, so times 3. Okay, so times 3 lah. Okay, so we add everything together. Okay, we add everything together here. Alright, so it's 160. Okay, it's 160. Yeah, okay, we just add everything together. So now 160 is the RAM, so we put here. So 128 divided by 160, which is the RAM of your iron 3 oxide. So key in to the calculator, 128 divided by 160. Okay, you will get 0.8. Don't forget to put in the unit. So the unit is mole. Okay, so now we found the mole of the iron 3 oxide already. Okay, so now we know the mole for the iron 3 oxide already. So now you can see iron 3 oxide, the mole is 0.8. So this is 0.8 mole. Okay, now when we know the mole of one substance, we need to find the mole of another substance, okay, that we want. Okay, so now how to find the mole of another substance? We do ratio. Fe2O3 is 1 and Fe is 2, 1 to 2. So we write it out. We just write out here. So refer to the ratio. Okay, refer to the ratio. So the ratio that we refer is the first one, Fe2O3, and also the Fe. So as you can see from the equation, ratio, look at the number at the front. So the number at the front is 1 and 2. Okay, so write down this first. Okay, so when we refer to the ratio, how to find the mole? How to find the mole of iron? Okay, so as you can see the ratio, this is 1 and this is 2. So iron is always double of the Fe2O3. Okay, you can see Fe2O3, the ratio is 1. Iron, the ratio is 2. So which means that iron, the mole always double. Okay, always double of the Fe2O3. Okay, so from here you can tell already. So what is the mole of your iron here? So iron, the mole is double of the Fe2O3. So Fe2O3, the mole just now we found 0.8. Okay, so 2 times 0.8. So the final answer here is 1.6 mole. Okay, 1.6 mole. So now we know the mole for iron already. So in the end, okay, the final answer they want is not the mole, right? The final answer, they are asking for the mass. Okay, they're asking for mass. So now we have the mole already. We can convert the mole to mass. So mole can convert to mass by using RAM. Mole change to something else, use times. Okay, so our mole is 1.6 multiplied. What is the RAM? So the RAM here is referred to this substance. This substance is iron. Iron, the RAM, as you can see, iron, the RAM is here. Okay, 56. Okay, so 56. Okay, so you don't take the iron 56 times 2 in front. The 2 in front is only for balancing the equation. Okay, the number 2 in front here is used to balance the equation. You don't include the 2 in your RAM calculation. Okay, so you don't include the 2 in the RAM calculation. Okay, so key into your calculator 1.6 multiplied by 56. Okay, so we get 89.6. Okay, we get 89.6. And the final answer, unit is gram, because we are looking for mass. Mass is in gram. So 89.6 gram. Okay, so the final answer is B, 89.6 gram. Okay, so this is how you do the question step by step. Okay, this is how we do the question step by step. Okay. Okay. Alright, so the next question, it's a little bit tricky. Okay, the next question here, it's a little bit tricky. So this is SPM 2016. Okay, so for this question, alright, so this question, as you can see, alright, they didn't give us a chemical equation. Okay, they didn't give us the chemical equation, so we need to write out the chemical equations ourselves. So we need to write the chemical equation ourselves. So first of all, we have this ammonium dichromate. Ammonium dichromate, the formula is given NH42 Cr2O7. So we write down first. So NH42 Cr2O7. So this is the dichromate. So the dichromate, now they go to ignite it, and then it produce 3 substances. So you should produce 3 products. So produce, so arrow, 3 substances. So the first substance is chromium 3 oxide. So we need to predict the formula for chromium 3 oxide first. So how to predict the formula for chromium 3 oxide? Chromium is something that you will use more in your Form 5. Only in Form 5, you will see more chromium. Form 4, we seldom heard about chromium. Okay, anyway, how to predict the formula? Chromium, the formula is Cr. When you see there is a bracket and there is a number inside, this number is the charge. So when you see chromium 3, the 3 means what? 3 plus. Oxide, we know the charge is O2 minus. So they have different charge. We cross it, 2 and 3. So when we cross the 2 and 3 here, you will get the final formula is Cr2O3. Yeah, Cr2O3. So this is the formula for chromium 3 oxide. So we predict the formula. We don't memorize it. So the next thing, we have nitrogen gas. Nitrogen gas is N2. Remember, most of the gas come in 2. Nitrogen gas is N2. So what else we have? So the last thing we have is steam. Steam is the gas form of water. Steam is the gas form of water. When water become gas, we call it steam. So steam is H2O. Okay, H2O. Okay. When the water become gas, we will get steam. So steam, the formula is H2O. Okay. So after we have this equation, we must make sure it is balanced. When we have chemical equation, we need to make sure it is balanced. So let's balance the equation here. Okay, so we have 2 nitrogen here, we have 2 nitrogen here, so it is balanced. Okay, hydrogen we have 4 times 2, 8. Hydrogen here we have 2, so you put 4 to make it become 8. Yeah, then as you can see, the Cr here got 2, the Cr here got 2, so it's balanced. Lastly, okay, the oxygen we have 7 on the left hand side. Right hand side, here the oxygen have 3, here the oxygen you have 1 multiplied by 4 at the front, 4, so 3 plus 4 also 7, so it's balanced. Okay, so now we already have the balance equation. So you don't expect every time they will provide you the balanced chemical equation. Okay, not every time they will give you the chemical equation one. Okay, so the worst case, if they don't give us the chemical equation, make sure you know how to write it out yourself. Okay, so now you have to identify what you have and what you want. Okay, so we are given 1.9 gram of NH4C2O7. So this substance, okay, we are given 12.6 gram. Okay, so what we are looking for, what is the calculation that we want to do? So we are looking for the volume of the steam. So we want to find the volume of the steam. So steam is H2O, so we want to find volume, so put the volume and put question mark. Okay, alright, so now we already know what we have and what we want. Okay, so first step, write a balanced chemical equation. Second step, ask ourselves what we have and what we want. So what is step number 3? Step number 3 is change anything to mole first. Change anything to mole first. So we have 12.6 gram, which is mass. So we will change the mass to mole by using RAM and divide. So the mass is 12.6. We need to divide with the RAM first. So we need to find the RAM for your substance. Okay, so let's find the RAM. So this is the RAM for your substance, NH4 bracket 2 Cr2O7. Okay, we need to find the RAM. So the RAM, how to find it, is given here. Okay, all the value of RAM is given here. Okay, so we just need to find it. Nitrogen is 14, so we have to multiply by 2. Hydrogen, 4 times 2, 8, so the RAM is 1. Chromium, the RAM is 52, is given here, 52. So, and we have 2 chromium here, so multiplied by 2. Okay, multiplied by 2. And we add with oxygen. Oxygen, the RAM is 16, and we have 7 oxygen. Okay, we have 7 oxygen here. Okay, so this is everything we have. Okay, so then we key into calculator. Yeah, we just key in this whole thing to the calculator. Okay, to do the calculations. Okay, all right, so if you key into calculator, you're gonna get 252. Okay, for the RAM. So now you key in. So now what we have is this. Okay, we take 12.6, divide the RAM, 252. So the answer we will get is 0.05. Okay, so the unit is mole. So now we found the mole for the substance. Okay, so now you can see we get the mole of this substance already, 0.05 mole. So how to find the mole of another substance? So we can use ratio. Okay, we can use ratio. So refer to the ratio. Okay, refer to the ratio. So the ratio we can refer to NH4 bracket 2 Cr2O7 and water. So the ratio is the number in front of formula, which is 1 and 4. Yeah, as you can see, the number in front is 1 and 4. Okay, so from the ratio we can find the mole of water. Okay, so how to find the mole of water? Okay, look at the equation here. So when we have 1 NH4 C2O7, we have 4 water. So 1 and 4 here. So water always 4 times. Water always 4 times of your NH4 Cr2O7. Okay, water always 4 times of NH4 Cr2O7. Okay, so 4 times. So how to get the 4 times here? The mole of the NH4 Cr2O7 is 0.05. So 4 times we times 4 here. So we're going to get 0.2 mole. Okay, we're going to get 0.2 mole. So now we found the mole already. Okay, we found the mole already for the water. So what is the final thing they want? Okay, not water here, sorry, steam. They want the steam. Okay, what is the final things they want? So for this question, in the end, we are looking for volume. We are looking for volume. So now we already have the mole. We can change the mole to volume. So mole and volume is related by molar volume. Mole change to something else times. So your mole is 0.2 multiplied with the molar volume. So what is the molar volume? Let's check the given one. So the molar volume is 24. So the molar volume is given to be 24. Yeah. So 0.2 multiplied with 24. So we will get 4.8. Yeah. And don't forget about the unit. Don't forget about the unit. So the final unit is dm cube because it is volume. Volume always put dm cube unless the question is asking for cm cube. Unless the question say they want the volume in cm cube, then okay, you put cm cube. Other than that, volume always in dm cube. So 4.8 dm cube. So let's check. Do we have the answer for it? Yes, 4.8 dm cube. Okay, so this is also a real SPM past year question. Okay, all right. So now we are done with all the objective question already. So all these are objective question. Okay, so then we have another 3 more. We have 3 more question here. Okay, these 3 question is in subjective question. So now we have 3 subjective question. So we will try to do it together. Okay, so okay, let's start with the first one. When 50 grams of calcium carbonate is added to hydrochloric acid, a chemical reaction occurs and produce calcium chloride, carbon dioxide, and water. Okay, calculate the maximum volume in cm cube for the carbon dioxide at the room condition. So how to do the question? Step number 1, always write a balanced chemical equation first. Write a balanced chemical equation. So we have calcium carbonate. Calcium carbonate, how to get the formula? We can predict the formula using the charge. Calcium is Ca2+, carbonate is CO3, 2-. They have same charge. We cancel the charge, stick together, we get CaCO3. Okay, CaCO3 is the formula for calcium carbonate. So calcium carbonate react with the next one, hydrochloric acid. Hydrochloric acid, the formula is HCl. So there are 5 substances that you need to memorize the formula. Hydrochloric acid, sulfuric acid, nitric acid, okay, ethanoic acid, and also ammonia. So you need to know the formula for these 5 substances. Okay, after they react, they produce something. Okay, calcium chloride, carbon dioxide, and water. So let's try to produce 3 products. So the first product is calcium chloride. Okay, so for calcium chloride, what is the formula? So we can predict the formula using the charge. Calcium is Ca2+, chloride is Cl-. Okay, so we do a cross method because the charge is different. So the answer is CaCl2. CaCl2 is the formula, okay, for the calcium chloride. Okay, so we also have two more products, which is carbon dioxide and water. So let's put in the carbon dioxide, CO2, and let's put in the water, H2O. Okay. So after you have the chemical equation, you must balance it. Okay, you must balance it. Okay. So use the step that we learned before to balance it. So I will do it faster now. I just put a 2 here to balance it. Okay. So make sure you know how to balance the equation. Make sure you know how to balance the equation. Okay. So now this is what we have. Okay. So now after we write the chemical equation, now we must now we go on with step number 2. So step number 2, we must know what we have and what we want. What we have and what we want. So we have 50 grams of calcium carbonate. So calcium carbonate here, underline, we have 50 grams. So what we want? So we are looking for the volume. This volume is carbon dioxide. So we underline the carbon dioxide and we write down the volume here. So this is what we want to find. Yeah. So now we know already what we have and what we want. Okay. So I should change. I should write like this. Write a better one. Okay. So now we already know what we have and what we want. Okay. So now we can kickstart chemistry calculation by getting the mole first. Okay, change everything to mole first. So we have 50 grams, which is the mass. We can change the mass to mole first. Mass and mole is related by RAM, and we use divide. So what is the mass? 50. So we need to find the RAM. We need to find the RAM first. Okay, so this RAM is referred to which substance? CaCO3. Okay, so we can find. Okay, so the RAM, okay, the RAM for CaCO3. Okay, so RAM is given here. Okay, you can add the CaCO3 together. So Ca is 40, C is 12, oxygen is 16 times 3. So all together is 100. Is 100. So 50 divided by 100, you will get 0.5 mole. Okay. So now we already found the mole for the CaCO3. Okay. So now once we found the mole for the CaCO3, we can continue to find the mole of another substance. Okay. So we can do it by using ratio. Okay, so we can refer to the ratio. So when we refer to the ratio, so the ratio that we are referring to is CaCO3 and also the CO2. So these are the two that we have. Okay, so the ratio, we look at the number at the front, is 1 to 1. So since we can see the ratio between the CaCO3 and CO2 is 1 to 1, so 1 to 1 means same, so we can expect the mole is the same as well. So when the mole of the CaCO3 is 0.5 mole, the mole for the CO2 should be 0.5 mole as well, because the ratio is exactly the same. So the mole of CO2, it's also 0.5 mole. Alright, so now we already found the mole for the CO2. Okay, so once we found the mole for the CO2, okay, what is the last step? So the last step is this, because we are looking for the volume. Okay, we're looking for the volume for the CO2, so we can do this. Okay, when we have mole, we can convert the mole to volume. Okay, to volume. So we will use molar volume. Yeah, we use molar volume. Okay, we're going to use the molar volume here. Okay. Alright. Okay. And the operation should be times. Mole change to something else times. So the mole is 0.5. times with the molar volume. So the molar volume is given to be 24 here. So it's given to be 24 here. So when we have 0.5 times 24, the final answer is 12. Okay. So what is the unit? Volume, the unit is dm cube. Okay. Volume, the unit is dm cube. But for this question, they ask us to give the volume in cm cube. Okay. This question, they want us to give the volume in cm cube. So we must remember 1 dm cube is equal to 1000 cm cube. Okay. 1 dm cube equal to 1000 cm cube. We learned this in lesson number 2. Okay. We learned this in lesson number 2. So to change dm cube to cm cube, we can multiply by 1000. So 12 multiplied by 1000. So you will get 12,000 cm cube. So that is the final answer. Yeah. Alright. So this is how we do the chemical calculation. We write a chemical equation. We balance it. We ask ourselves what we have and what we want. We convert whatever we have into mole. We use ratio, find another mole. Okay, we use the ratio in the equation to find another mole. So once we get the mole, we can change the mole to the final quantity that we want. In this case, it is volume. Okay, so that's how we do it. Okay, so it's all started with a good and balanced equation. So you must be able to write a good and balanced chemical equation. Okay, all right, so let's move on to the next one. Okay, so the next question. So we have the zinc nitrate decomposition. Decomposition means breakdown. So decomposition means breakdown. So we have a zinc nitrate in the first place. So let's predict the formula for zinc nitrate. So zinc nitrate, we can predict the formula by using the charge. So zinc, the charge is Zn, 2 plus, nitrate is NO3, negative. Yeah. So they have different charge. We use the cross method. So then we will get the formula Zn NO3 2. So this is zinc nitrate. So zinc nitrate decompose will produce zinc oxide. So zinc nitrate produce zinc oxide. So zinc oxide, same thing. You can predict the formula from the charge. The formula for the charge, the zinc is Zn 2 plus. Oxide is O2 minus. Oxide is O2 minus. So they have same charge. We cancel the charge and stick together. ZNO. So ZNO, this is the formula for your zinc oxide. Okay. So what is the next thing? So we have nitrogen dioxide. So nitrogen dioxide, what is the formula? Nitrogen is N. Dioxide. Di stands for 2. Oxide is oxygen. O2. So we have NO2. And lastly, we have oxygen. So oxygen here, it's O2. Okay. So now we already have all the formulas. So after that, we need to balance the equation. Okay, we need to balance the equation. So we have one zinc on the left, one zinc on the right. So it is balanced. Okay. So then the nitrogen, we have 2 on the left. Okay, we have 2 nitrogen on the left. So the nitrogen on the right, we can put a 2 to balance it. Okay. Just put a 2 here to balance it. Okay, so after we write the equations, we need to balance it. So, alright, so we have one zinc on the left, one zinc on the right. So we have 2 nitrogen on the left, 2 nitrogen on the right. So oxygen on the left, 3 times 2. So we have total 6 oxygen on the left. On the right, this one we have 1 oxygen. So here we have 2 times 2, 4 oxygen, and here we have 2. Okay. So total 1 plus 4 plus 2, 7. Okay. So to make the oxygen balance, okay. So we have 6 and 7, odd and even number. We have odd and even number. So we can balance it by putting a 2 in front here and rebalance the whole thing again. Yeah. So when we rebalance it, the whole thing again, okay. Now the zinc on the left got 2. On the right, the zinc must put 2. Now the nitrogen on the left hand side, okay. Now the nitrogen, we have 2 times 2, 4. So we have 4 nitrogen on the left. On the right, we need to put a 4. Okay. Then the oxygen, okay. On the left hand side, we have 3 times 2, 6. 6 times 2, 12. So we have 12 oxygen on the left. On the right hand side, the oxygen here, we have 2. The oxygen here we have 2 times 4, 8. And here at the last oxygen is 2. So 2 plus 8 plus 2 also 12. Okay. So now it is balanced. So now the equation is balanced already. Yeah. Okay. So after we have the balanced equation, now we need to ask ourselves what we have and what we want. Okay. Ask ourselves what we have and what we want. Okay. So we have 672 cm³ of nitrogen dioxide. So nitrogen dioxide is NO2. So we have 672 cm³. Okay. So this is what we have. So what we want. So we want to find the mass of zinc nitrate. So this is zinc nitrate. So we are looking for the mass. Okay. Okay. So now we will kickstart our calculation. Okay. So to do the calculation, first of all, we must convert whatever things we have into mole. Always convert whatever things we have into mole first. Okay. So we have 672 cm³. So cm³ means volume. Okay. So we have volume. So we can convert volume to mole first. So volume and mole can be converted using molar volume. Okay. We use molar volume. And the operation is divide. Okay. So the volume we have is 672. The molar volume is given here. The molar volume is 22.4. Okay. Is 22.4. Okay. So but the 22.4, it is in dm³. Okay. So 672 is cm³. 22.4 is dm³. So the unit is different. So we can change the dm³ to cm³. So by multiply 1000. So if we multiply 1000, okay, if we multiply 1000, so we will get, okay, 22,400 cm³. Okay. So on top, 672 cm³, we copy back. Yeah. So now both are in cm³. Then only you can do the calculation. You cannot do calculation when one is cm³ and one is dm³. Okay. So that is what we do. Okay. So the next thing, okay, the next thing is you key into calculator, then you will get a mole ready. So the mole is 0.03. Okay. So now we get the mole ready. Yeah. So this mole that we get refer to the nitrogen dioxide. So the 0.03 mole is referred to nitrogen dioxide, NO2. Okay. So now we got the mole already. Okay. So the mole that we have is for NO2, but we need to find the mole of another substance. Okay. When we have the mole of NO2, we need to find the mole of another substance, which is ZnNO3. So we need to refer to the ratio. Okay. We need to refer to the ratio. So refer to the ratio. Okay. So the ratio we refer is zinc nitrate and also the NO2, nitrogen dioxide. So the ratio, we copy back the number at the front. So number at the front is 2 and also 4. Okay. So how to find the ratio? How to use the ratio here? Okay. How to use the ratio? Okay. So as you can see, the mole for NO2 we know already. NO2, the mole is 0.03. So now what is the mole? Okay, what is the mole of the ZnNO3? What is the mole of the ZnNO3? Okay, how to find this? Okay, how are we going to find this? Okay, so to find the mole here, we have to use a ratio. This is 4 and this is 2. So 4 and 2. So 4 and 2 means what? The zinc nitrate always half of the NO2. NO2 got 4 portion, but ZnNO3 here only got 2 portion. Okay, so which means that zinc nitrate always half of the NO2. Okay, so half. So how to get this? Okay, so from here you will get the mole for the zinc nitrate. Okay, so let's find the mole of the zinc nitrate. Okay, so the mole of zinc nitrate is half of the mole of NO2, because NO2 is 0.03. Okay, the NO2 here is 0.03. So for zinc nitrate, is half of the 0.03. So we take 0.03 divided by 2. So you get 0.015 mole. Okay, so this is the mole for the zinc nitrate. Okay, just a simple ratio calculation. This is more to do with mathematics. Okay, nothing to do, I mean, not to say nothing lah. It's not so much with chemistry. It's more on your mathematics. Okay, so now we already know the mole for the zinc nitrate. So in the end, what we want, in the end, we are looking for mass. Okay, so let's do the final step. So when we have mole, we can convert the mole to the mass. So mole and mass can be converted using RAM. Mole and mass can be converted using RAM. So when mole change to something else, we use times. So 0.015 mole need to multiply with the RAM. So now we need to find the RAM for the zinc nitrate. Okay, we need to find the RAM for our zinc nitrate. So how to find the RAM? We can refer to the value given here, or the value given here. Okay, so zinc, it is 65. Nitrogen, it's 14. You have 2 of it. Oxygen, the RAM is 16, and you have 6 oxygen. Okay, so we just add everything together. Yeah, we have all the value here. We just need to add them together. Okay, so we will get 189. Okay, so 189 is the RAM for the zinc nitrate. Okay, 189 is the RAM for the zinc nitrate. So we put 189 here. So key into calculator. Okay, 189 multiplied with 0.015. So we will get 2.835. Okay, or you can round off to 2.84 also can. Yeah, 2.835. Okay, so that's the answer. Okay, and don't forget to put in the unit. Don't forget to put in the unit. Since we are looking for mass, the final unit should be in gram. Okay, the final unit should be in gram. So 2.835 gram. So that is the final unit. Okay, so this is how you do the step-by-step calculation. Okay, so last question. Okay, so this is the last question. Sulfuric acid react with 40 grams of the sodium hydroxide to produce sodium sulfate and water. Okay, so this is the last question. So first of all, we need to write a balanced chemical equation. We need to write a balanced chemical equation. So sulfuric acid, the formula is H2SO4. Okay, we learned this in your lesson number 6. We learned in lesson number 6. If you need to, you can revise back. So sulfuric acid react with sodium hydroxide. So sodium hydroxide, we can predict the formula from the charge. Sodium, the charge is Na plus. Hydroxide, the charge is OH minus. So they have same charge, cancel the charge and stick together, NaOH. So NaOH is the formula for the sodium hydroxide. Yeah. So they will produce sodium sulfate. So sodium sulfate, what is the formula? Same thing, we don't memorize, but we predict it. Sodium sulfate, sodium, the charge is Na plus. Sulfate, the charge is SO4, 2 minus. Okay, so the charge here. So they have different charge. We do cross method. So when we do cross method, the formula is Na2SO4. Okay, sodium sulfate. Lastly, we have another product is water. So water, it's H2O. Okay, all right. So when we write the chemical equation, we need to balance it. Okay, we need to balance it. Okay, so let us balance this equation. Okay, so when I balance the equation, I won't balance the H first because there are so many H here and there. So I won't balance the H. I balance other thing first. So let's say here, look at SO4. I have SO4 here, I have SO4 here, so it's balanced. I have 1 sodium here, I have 2 sodium here, it's not balanced, so I can put a 2. Okay, then after I put a 2, my oxygen here got 2. So my oxygen here has 1, so you put the 2 here as well. Lastly, the hydrogen. Hydrogen now how much we have? Here the hydrogen have 2. Here the hydrogen multiplied with 2 in front. So 2 and 2 is 4. So on the right hand side, the hydrogen here you have 2 times 2, 4. So everything is balanced now. Okay. So now we already have a balanced chemical equation. Okay. So once we have the balanced chemical equation, so the next thing we should identify what we have and what we want. Okay, we should know what we have and what we want. So what we have, 40 grams of sodium hydroxide. So the sodium hydroxide here, you underline. Okay, sodium hydroxide here, you underline. And you put 40 grams. This is what you have. So what you want, okay, what you want, mass of the water. So you underline the water. So you write down what you want, mass. Okay. So by doing this, we already identified what we have and what we want. Okay. So now we can kickstart our calculation by converting what we have into mole first. So we need to convert what we have into mole first. Okay. So we have 40 grams, which is mass. So we can change the mass to the mole first. So mass and mole, we can use RAM. Okay, we can use RAM to do it. Yeah. So operation, divide. Yeah. Okay, so the mass is 40. So we need to divide the RAM. So now we need to find the RAM first. So what is the RAM that we want to find? The RAM we want to find is for sodium hydroxide. Okay, so sodium hydroxide is NaOH. So when we find RAM, remember the number at the front, the number 2 here, don't include in RAM calculation. All the number in front equation, we use it to balance the equation and use it to do ratio only. I repeat, all the number in front your chemical equation, you use it to balance the chemical equation and you use it to do ratio only. You don't use the number in front here to calculate RAM. So when we do RAM calculation, the number in front, just ignore, don't bother. Yeah. So what is the RAM for NaOH? So Na, the O and the H, all the RAM is given here. Okay. So let's add together. Na is 23. Okay. Then the O is 16, H is 1. Add together, 40. So 40 is the RAM for NaOH. Okay. So then we divide the RAM here. Just put 40 in. 40 divided by 40, we get 1. Okay, we get 1. So the unit is what? The unit is mole. Since we are looking for mole. Okay. So now we found the mole already. So now we found the mole for the NaOH. Okay. So now when we know the mole of one substance, we can find the mole of another substance. Okay, we can find the mole of another substance by using ratio. Okay, so now we refer to the ratio. Okay, we refer to the ratio. So which ratio we are referring to? Look at the underline. Look at the underline. So we underline NaOH and water. So we just play ratio with these two, NaOH and water. So ratio, we copy the number at the front. So NaOH, the number in front is 2. Water, the number in front is 2. 2 and 2. So 2 and 2 means what? The ratio is the same. When the ratio is the same means the mole is the same. Okay. Remember, when the ratio is the same, the mole will be the same. Okay. You have one portion, I have one portion. We are the same. You have two portions, we have two portions. We are the same. Yeah. So we know the mole for the NaOH is 1 mole. So the water is exactly same as the NaOH because the ratio is 2 to 2. So from here you can write mole of the water also 1 mole. Yeah. So water also 1 mole. Okay. So now we found the mole of water already. So let's do the final step, the mass. Okay. The final step is the mass. Okay. So how to find the mass? So when we have mole, we can convert mole to mass easily. Mole and mass we can convert using RAM. Okay. So mole can change to mass by using multiplication. Okay. So our mole is 1 mole. So now we need to find the RAM. So this RAM is referred to what? Okay. So since we are looking for the mass of the water, so the RAM is referred to the RAM of the water. Okay, so we have to write RAM of the water. So when we find the RAM of water, we add together. Water has hydrogen. Hydrogen RAM is 1. We have 2 hydrogen, so multiplied by 2. So water, you have oxygen, RAM is 16. So add together 18. So 18 is the RAM of water. So same thing, remember, although you see there are 2 water here, the RAM you don't need to multiply by 2. Because the number 2 in front here is only used to balance the chemical equation and also used for the ratio. Okay, the number in front is used for ratio and used to balance equation. The number 2 in front don't need to use for RAM calculation. So please don't multiply the 2 at the front when you do RAM calculation. Okay, so many students make these careless mistakes. Okay, so it's 18. So 1 times 18, it's 18. And the final unit, since we are looking for mass, the final unit for mass is gram. So it's 18 gram. Okay. So there are total 10 questions that we discussed in this video lesson. Okay, in this video lesson tutorial, we discussed total 10 questions. Okay, so there are some objective question and there are some subjective question as well. Okay, so make sure you know step by step how to do those questions. So some of the questions here are past year question. Some of the questions here are real SPM past year question. Okay, so make sure you understand the concept, how to do it, okay, step by step. Okay, so most importantly, you understand the strategy. Okay, whenever you want to do the calculation that involve chemical equation, it's always a 5 steps process. It's always a 5-step process. Okay, step number 1, write a balanced chemical equation. Step number 2, ask yourself what you have and what you want. Step number 3, convert what you have into mole first. Okay, whatever thing you have, just convert them into mole first. Step number 4, by using mole ratio, find the mole of another substance. Okay, so how to use the mole ratio? Refer to the number in front your chemical equation. In chemical equation, all the number at the front represent ratio. Okay, we'll use the ratio to find another mole. So last one, step number 5. Once you get the mole, you change the mole to the final quantity that you want. Okay, change the mole to the final quantity you want. For example, change the mole to the mass, change the mole to the volume. Okay, something like that. Okay, so this is how you do the calculation step by step. Okay, so do it slowly, do it carefully. Yeah, don't keep on thinking to do shortcut. Okay, so do it in a proper way. Okay, do it step by step, then you will be able to get the answer. Okay, all right, so guys, I think that's all for this tutorial. Okay, so yeah,